So here we're dealing with right triangle trig. So when you have a right triangle and you know one angle measure other than the 90-degree angle and one of the side lengths, you can use one of the three trig ratios, either sine, cosine, and tangent, to find your missing side length or angle measure. For right now, we're going to focus just on side length. So the sine of angle A is opposite over hypotenuse. Cosine is the length of the adjacent leg over the length of the hypotenuse, where tangent is the length of the opposite leg over the adjacent leg. An easy way to remember these ratios is SOHCAHTOA. So SOHCAHTOA. Where in this case, the O and the H stand for opposite over hypotenuse, and then the S stands for sine. The K is adjacent over hypotenuse, and that the C is cosine, and then T for tangent, and you have opposite over adjacent. And using these, we can set up ratios, or basically fractions, for the relationships of the sides of the right triangle in reference to a particular angle. So in our first example here, we want to state the sine of T. So T is our reference angle, and we should remember that sine is opposite over hypotenuse. So the side opposite T would be 8, and the hypotenuse is 17. So that's our trig ratio there. Cosine, adjacent over hypotenuse. So that means we're going to have the side beside it. So this is 15 over hypotenuse, which is 17. And then tangent is opposite over adjacent. So that means 8 over 15. This time we're looking at sine of G, cosine of G, and tangent of G. Well, remember sine is opposite over adjacent. So if we're looking at G, opposite of G would be 15. Oh, sorry, the sine of G, sine is not opposite over adjacent, it's actually opposite over hypotenuse. That's my bad. And so the opposite is 15, the hypotenuse would be 17. There we go. Cosine, adjacent over hypotenuse. Your adjacent side would be 8. Your hypotenuse is 17. And then tangent of G is going to be opposite over adjacent. So opposite would be 15, adjacent would be 8. And these are our trig ratios. So now understanding how to create the ratios is what we use then to find missing side lengths. So here we have an example where they've given us an angle, 54, and they've given us the hypotenuse, 17, and they've asked us to find W. So the first thing we need to do is figure out the relationships of the sides to this angle. So from here, W has to be the opposite side, and 17 is your hypotenuse. Well, I have measurements at opposite and hypotenuse, so that means I'm dealing with sine. So in order to solve this, I'm going to set up a proportion. I'm going to take the sine of the angle measure, so the sine of 54, over 1 equals opposite over hypotenuse. Now, to solve proportions, we've always just cross multiplied. So we'll take W times 1 gives us W, and then the other way is 17 times the sine of 54. Well, our variable is all by itself, so we can go ahead and plug this into our calculator, and we should get W to equal 13.75. All right, here we'll repeat the process. We're starting with an angle measure of 28. Now we need to determine the relationship to the side lengths. The 1.0 would be opposite. This side here is hypotenuse, but there's no measurement there. And then the other side then must be the adjacent. So right now we have measurements at adjacent and opposite. Well, opposite and adjacent is tangent. So the tangent of 28 degrees over 1 equals opposite over adjacent. So now we'll go ahead and cross multiply, and we've got W times the tangent of 28 equals 1. Well, we want the w to be by itself, and the only way we're going to do that is if we divide both sides by the tangent of 28. So right now, what we can do is we can plug this part of the problem into our calculator, or 1 divided by the tangent of 28. And when we do this, we get that w equals 1.88 roughly. Same idea here. We're going to figure out the relationship to our reference angle. Well, this side would be opposite, but there's no measurement there. The side across from the right angle is your hypotenuse, and that means this is the adjacent because it's beside it. We have measurements at hypotenuse and adjacent. Adjacent hypotenuse would be cosine, so we've got cosine of 33 over 1 equals w over 4.5. At this point, we want to cross multiply our values, so w times 1 would be w, and then 4.5 times cosine of 33 gives us 4.5 times cosine of 33. Since our variable is all alone, we can go ahead and plug this into our calculator, and we should get w equals 3.77. Here, we've got a reference angle again. This time it's 39. Across from 39 is x, which would be our opposite side. And then there's no marking at the hypotenuse, so that means 15 is our adjacent side. So opposite and adjacent tells us we're dealing with a tangent. So the tangent of 39 over 1 equals x over 15. So now we're going to cross multiply. So when we cross multiply, we get x times 1 is x, and then 15 times the tangent of 39. Well, since our variable x is all alone, we can go ahead and plug that in our calculator, and we're going to get x equals right around 12.15. A section of Filbert Street in San Francisco rises at an angle of about 17 degrees. If you walk 150 feet up this section, what is your vertical rise? So here, what they're telling us is that this part here, the angle here is 17 degrees. If you're walking up the part, you're walking up 115 feet up the vertical ramp piece, or the slanted ramp piece, and they're looking for the vertical rise, which would put that measurement there. So right now, they've given us an angle, they've given us the opposite side, and they've given us the hypotenuse. Opposite and hypotenuse gives us the sine function, so the sine of 17 over 1 equals x over 150. At this point, we want to cross multiply, so x times 1 gives us x, and then 150 times the sine of 17. And so at this point, we can go ahead and plug this piece into our calculator, and we get that x, or the vertical rise, is right around 43.86 feet. In addition to being able to find side lengths using trig, you can also find angle measures. But in order to find angle measures, you need to be able to use the inverse of the cosine, sine, and tangent functions. So let's start off trying to find an angle measure. Here they have us trying to find angle x. So we're looking for this angle measure here. Well, in reference to that angle, they've given us measurements for the opposite side and the hypotenuse. So I know I'm dealing with sine here. So I'll set it up. I have the sine of x equals opposite over hypotenuse. Well, here's the problem. I don't know how to get the x outside of this because it's embedded in the function. Well, the only way to do that is if we, instead of using sine, we use the sine inverse. And so when we take the sine inverse, the x will be left alone, and instead we're going to take the sine inverse of 6 over 10. To access the sine inverse on your calculator, you press the second key and then the sine button. And so what we want to do is we want to put this into our calculator just like this. And it will tell us that our x, or our x angle, should equal 36.9 degrees, roughly, or right around 37 degrees. So basically, when you're using the inverse of your trig ratios, you're going to take whatever trig ratio you get, in this case we use sine, and then we're going to switch the x and our ratios places and use the inverse. And you'll see as we practice this, it becomes more familiar. So in the second one, we're also looking for angle x here. Angle x is here. So right now I know that I've got the hypotenuse and the adjacent side. Adjacent hypotenuse is cosine, so I've got cosine of x equals 15 over 20, or adjacent over hypotenuse. If I'm looking for the angle measure, I'm going to use the cosine inverse, and instead of having x there, I'm going to put the ratio there. And this should tell me what x equals. So if I plug this into my calculator, cosine inverse of 15 over 20, I should get that x is right around 41.4 degrees, or if we want to round down, we can just say 41 degrees. All right, for the next one, they've asked us to find the measure of angle y. Well, y is here. We've got the opposite side and the adjacent side. Opposite and adjacent is tangent, so I've got the tangent of y equals opposite over adjacent. I'm looking for an angle measure, so I'm going to use the inverse. So y is going to equal the tan inverse of 100 over 41. So in this case, when I plug this into my calculator, I'm going to get y to equal 67.7 degrees, or right around 68 degrees. For extra practice, we'll go ahead and look at the last two wrap-up problems on your notes. So for wrap-up problem number 7, they've given us the angle, and they've given us the side length. So that's opposite, and this is going to be the adjacent. So to find the side length, we're going to take the tangent of 39 over 1, and we're going to set up a proportion, just makes it easier, equals x over 15. At this point, we want to cross multiply. So x times 1 is x, and then 15 times the tangent of 39. At this point, we want to go ahead and plug this in our calculator, and we should get that that length for x should be 12.15. Question 8 in this case, this time we're looking for an angle measure. So we're looking for this angle here. We've got opposite and hypotenuse. Opposite hypotenuse is sine, so I've got the sine of x, and you can put that over 1 if you want, equals 27 over 32. Well, we're looking for an angle measure, so we use the inverse. So that means x is going to equal the sine inverse of 27 over 32. So when we plug this into our calculator, we should get the angle measured for x to equal 57.5 degrees.